There's this thing called WebMCP. It's a mechanism for websites to expose tools to AI agents. It's a proposed API where the site structures what actions are available and what inputs they need. That's what we're checking out today.
AI can already operate browsers, right? So what's actually changing?
Before this, AI had to guess how to operate a page just from the on-screen text and the DOM. But when a site gets updated and the layout or labels change, things get tricky. The agent sometimes has to go hunting for the right action all over again. With WebMCP, the page itself explicitly declares the actions it wants to expose as tools. The agent can then call the page's own logic by passing structured arguments.
But who decides which actions get exposed as tools?
The page author does. Not every feature on a site automatically becomes a tool. The current registration API is Register Tool on document.modelContext.
So is this already a standard I can use in regular Chrome?
Not yet. It's still just a proposal. It's being discussed in a W3C community group, and Chrome is running an origin trial. It's neither a finalized standard nor a generally available feature.
Can the AI products we normally use actually call these tools?
Whether Claude, ChatGPT, or Gemini can call them, that's still unconfirmed. When an agent operates a site the old way, it works in separate steps. It first has to understand the screen, then actually execute the action, filling out a form on a page and submitting it. For a human, that's the whole action. But for an agent, it first has to map the text shown on screen to the DOM structure. Next, it locates the target element using selectors, or its position on screen. It also has to infer from the surrounding context whether that element is an input field or a button.
So it's checking all that before it even clicks anything.
If the guess is right, the action goes through. But sites get updated over time, right? If a button's label changes from submit to confirm booking, the clue that used to work no longer applies. If the DOM nesting changes, the old selector might not match anymore. And if a layout change moves things around, any action relying on coordinates ends up off target. If the action doesn't produce the expected result, it tries another candidate. So the fragility all comes down to one part. The agent has to guess the meaning of an action from the screen. The longer the sequence of steps, the more searching and retrying tends to pile up at each stage. With WebMCP, the site registers each action's name and description as a tool. The required input can be laid out in a structured way with input schema. The actual logic to run gets tied to the execute callback.
Name, description, arguments, that sounds a lot like a regular MCP tool.
Yeah, the whole idea of a tool is shared with MCP. For any action that's been exposed, the AI can just pick the registered tool. Then it passes things like the target or the quantity as defined arguments. The page can run its existing functionality using those arguments. There's no need to reproduce which button to click in what order. Like before, what you want to do connects directly to which process actually runs. The screen for humans stays exactly as it is. Only the actions being exposed get declared explicitly behind the scenes.
So does that mean the agent doesn't need to read the DOM at all anymore?
Not quite. What gets reduced is the guesswork needed to find an exposed action. When it comes to understanding the page as a whole, reading the DOM is still necessary. The site defines the tool's contents through an API and exposes it to the agent. You pass a single tool to register tool on document.modelContext. That tool is made up of 4 parts. Name is the identifier the agent uses to recognize the action. It's this name that specifies what gets called. Description explains in natural language what the tool actually does. It gives the agent a clue for understanding the purpose and choosing the right action. Input schema is a JSON schema that defines the shape of the input it accepts. You write the required fields, and each field's type in here. The agent passes arguments that match that format. Execute is the handler that calls the page's existing functionality with those arguments. It's the piece that takes the input and connects it to the actual action. The page author designs all of this, from the unit of functionality being exposed down to these 4 elements. Even on the same page, which functions are available can change depending on the current state. You can register different tools before and after login. You can expose only the tools that are relevant to whatever's currently selected. Depending on the screen that's currently open, you can leave out any tools that don't apply. So the set of registered tools can grow or shrink dynamically on the page.
Oh, so it's not fixed once it's registered.
To cancel it, you use an abort signal to unregister the tool. Register tool is the JavaScript-based entry point. There's also a proposed declarative HTML form. It's an approach built on HTML form elements and standard input fields. The browser assembles the input format and how it gets executed. With a declarative approach, you can reuse an existing form's input validation. The submit handling and page navigation can carry over as is too. The idea is that you don't have to implement the same logic twice in JavaScript. With the imperative approach, the page author registers the tool in JavaScript. The author explicitly provides the input schema and execute as well.
Is the declarative version as far along in the spec as the imperative one?
Not yet at the same stage. The plan is to put together the related documentation later. It's not just the exposing side that needs a spec. The calling side needs one too. Get tools and execute tool on the calling side are also still marked to do in the spec. At this point, the finer details of how to call them haven't been settled yet. WebMCP and server-side MCP differ in where the tool gets exposed and what role it plays. When you hear MCP server, I think what comes to mind is something running outside the browser. Server-side MCP connects to a service without going through any screen or tab. With WebMCP, the page you have open is the one exposing the tools itself, and the tool's logic runs inside the browser where that page is running.
If I'm already logged in on the page, can it use that state too?
It can. The tool has access to whatever login state the visitor has on that page, and it can factor in the page state at that moment when it runs. There are two axes for telling them apart: what it connects to and where it executes. Connecting to a service from outside versus running inside an open page. The only thing they share is the idea of exposing something as a tool.
So is this basically MCP's communication moved into the browser?
Not quite. It's not a spec that just ports the same communication protocol over. The browser has origin-based boundaries. It's also subject to constraints from permissions policy. The tool runs inside the same page as the DOM, and the tab that page is open in has a limited lifespan. It has to work within these web-specific constraints. WebMCP isn't about MCP communication as a whole. It's narrowly focused on exposing actions within a page. That's why WebMCP surface area is small, scoped for the browser. It's not meant to replace server-side MCP.
So in the end, which one should you actually pick?
If you want to use the current screen and the permissions that person has on the site, go with WebMCP. If you're connecting to a service without a browser open at all, server-side MCP is the better fit. It's not that picking one means you can't use the other. The same service can run server-side MCP and still expose WebMCP tools from whatever page is currently open. Functionality and data meant to be used from outside get left to the server side. Actions that rely on the screen and the visitor's state live on the page side. Within the same service, a setup that uses both together works just fine. WebMCP is still just a proposal, but vendor-specific implementations are already showing up around it. Cloudflare has a feature that adds a WebMCP bridge to existing sites, but it's not the WebMCP standard itself. It's a vendor implementation offered as a developer preview that's still in testing. In the dashboard, there's a Labs section under Agent Readiness. That's where the Enable WebMCP toggle shows up. Once you turn it on, you can also choose which tool packs to use.
So if it's just the dashboard, you don't have to touch the site's code.
Cloudflare says you can add it without modifying the origin at all. The HTML response gets routed through workers. That's where HTML rewriter injects the bridge script. That script is bridge.js, served from the same origin. Bridge.js loads whichever tool packs you picked. Then it registers them as tools on document.modelContext. That's the API I defined in the WebMCP proposal. There are two tool packs you can see in the dashboard: Content Credentials and Site MCP Server. Both are options Cloudflare provides.
Content credentials, does that mean it signs images?
No, what this tool pack reads is provenance info already on the image. It passes the C2P or provenance data from images on the page to the agent. It's not a feature that generates new signatures or provenance. Signing images is a separate feature over on Cloudflare images. Cloudflare says it can preserve and extend the signature chain even after delivery transforms, but that's on the images side. It's not part of the WebMCP bridge feature. The other one is the Site MCP Server tool pack.
Does this one need an MCP server on the site side?
Right? The site's own MCP server becomes the source that publishes the tools. The Cloudflare implementation then relays the tools published there. It relays them to the agent running inside the browser. This tool pack's role is to bridge already published MCP tools. The WebMCP proposal itself is separate from Cloudflare's injection and tool packs. WebMCP also lets you decide who gets to see a tool and with what permissions it runs. The scope you can expose tools to depends on the iframe's origin.
If I register a tool inside an iframe, who can actually see it?
The browser acts as the go-between for discovering registered tools. It's not a design where the page and the agent connect directly without limits. Discovery and execution of published tools happen under the browser's control. An iframe with the same origin as the top-level document is expected to be usable by default. An iframe from a different origin isn't included by default. You need to set tools in the allow attribute to delegate it explicitly.
Does the browser create some new permission just to run it?
No, it doesn't. Execution uses the visitor's current login state and whatever permissions that visitor already has on the site. Turning on WebMCP doesn't automatically grant more permissions. An action that isn't allowed on the site won't become allowed just because of WebMCP. There's also permissions policy as a way to block publishing altogether. With permissions policy, you can set tools to empty. Once you do that, the document can no longer publish WebMCP tools. How the document is embedded also affects how far it can be exposed. There's another proposal too, called Expose To. It narrows down the origins of the agents a site has set up. That way it can limit exactly who gets to see the registered tools. But Expose To is also just a proposal. Nothing's settled there yet. That includes things like whether it's shown to built-in agents by default. The overall design of who tools get exposed to is still undecided. WebMCP emphasizes collaboration that happens on a browser screen a human can see. Even so, there is still a matter of confirming an action that has side effects before it runs. Whether the browser or the agent side handles that is undecided. You also need to watch out for malicious or compromised pages. A tool's name, description, input format, and return values could all be used to steer an agent's judgment. That has been raised as one of the open concerns.
So once it's standardized, can we trust the tool descriptions?
What gets standardized is just how the tool gets handed over. Even once that's settled, checking what's actually inside is still up to whoever's using it. The calling side of WebMCP splits into two things. One is adoption in actual AI products. The other is the testing tools available to developers. Developers building compatible pages want to confirm whether Chrome can actually call their published tools. For that verification path, Chrome has a public trial set up. WebMCP is a proposal still under discussion in the W3C Web Machine Learning Community Group. Chrome is also still at the stage of running its public trial. The Origin trial covers Chrome 149 through 156. Meanwhile, Cloudflare's testing docs still have different numbers left in them. The Chrome 146 reference left in the browser run docs is outdated. It's not the number used for the actual public trial.
What do you need to enable it on a live site?
First, you register for Chrome's Origin trial. You serve a token for your target origin from the page. There's a separate entry point for local testing. In Chrome's flags screen, you turn on Enable WebMCP testing. It keeps public site trials and local-only testing separate. Having a testing entry point is different from actual adoption in mainstream AI products. The current state for Claude, ChatGPT, Gemini, and Perplexity is hard to confirm. There's no official material confirming they can call WebMCP. There isn't primary source documentation that could confirm or deny support either way.
So if a product can run a browser, it can call WebMCP too.
Generic browser features alone don't demonstrate WebMCP adoption. Support for server-side MCP isn't evidence of adoption either. The absence of documentation can't be turned into a claim of no support. For verifying the calling behavior, you can use Cloudflare Browser Run. It's a feature for opening a WebMCP-compatible page and checking the calling side. It's a completely different thing from the feature that injects the bridge script into a site. In Browser Run, you create a testing session, you run Wrangler Browser Create with the lab, and keep alive 300 options. That starts a testing session that stays alive for 300 seconds. You call list tools on Navigator, model context testing, that gets you back the list of tools the page has published. To run one, you pass structured arguments to execute tool.
Can you write that Navigator API into a site's actual implementation?
Navigator model context testing is a testing-only entry point. It's separate from document.modelContext, which page authors actually use.
So being callable in testing is still different from adoption in mainstream products?
WebMCP isn't a proposal to get rid of the human-facing screen. The screen stays. The site just also publishes the meaning of an action and what input it needs. There's the standard proposal, the vendor implementation, and the environment for trying it out. It's better not to mix those together. Neither what Cloudflare injects at delivery time nor the tool packs are the standard. Chrome's origin trial and browser run are just entry points for trying it out.
Even once it's standardized, that doesn't mean you can trust the tool descriptions.
What gets settled is just how it's handed over. What the page actually writes isn't settled. How to guard against a malicious description, and who's responsible for checking, none of that's settled. Whether the major AI products can actually call it isn't something we can confirm officially either. Right now, it's still at the stage of being discussed in a W3C community group. What we can confirm goes only as far as the public trial on Chrome 149 through 156. How the calling side behaves is still going to be decided from here, I think.
If it does catch on, maybe people will end up operating websites themselves a lot less.